Section 1.4, shifting, reflecting, sketching graphs, basically transformations. So we're going to jump right in and do a couple of examples. Hopefully you have your notes printed out in front of you. I'm not going to go over the first page of these, but you might want to do that before we get into this example. So if you pause now and then read that would probably be best. So I'm going to go ahead and proceed following those notes from the first page. The first thing I'm going to do is I'm going to rewrite our g of x function. So I would like the g of x function to be set up so that I can see the a, b, c, and d all in the function. So I'm going to write that as a -1. Bring the f, factor out the b, and then just bring the 1 down. So now that I have this set up, I can figure out what's going to be happening with each of the x's and with each of the y's. But before I do that, I think I'm going to go off to the side over here and figure out what my mother points are. So I'm just going to extract them from the graph and write them down in a table. Okay, now I've got all of the points identified from the graph, and I'm going to take a look at my transformation and just start extracting things that need to be done. So the first thing that I'm going to do is take my x's and I'm going to divide them by the b. The b is the number that I factored out. So let's go through and identify up here what b is. So that, my 3 is my b. So I'm going to take my x, and it looks like multiplication, but inside the brackets or parentheses, it's always the opposite of what you think. So I'm going to divide by b. Then, the next thing that I'm going to do is I'm going to figure out what I'm supposed to be doing with my y's. Well, my y at this point has to do with the a. So I take a look back at the equation, and I look at the a. With the y, those are the exact things that you do. So I'm going to take my y and I'm going to times it by the a. So I'm going to take my previous table of values and I am going to take the x's, divide them all by b, and take the y and multiply them all by 3. Excuse me, a. So let's go ahead and put that number there too. So with the b was 3, so I'm going to take my x and I'm going to divide by 3. And then with my y, I'm going to times by -1. I'll go ahead and put these into the table. So, dividing by 3, don't be afraid, you're going to get some ugly fractions sometimes, it happens. So, dividing by 3, I'm going to get a -4/3, a -2/3. Again, just dividing by 3. And then times it by -1 just flips the signs on everything. Moving on, the next thing that I do with my x's is the other value that's left inside the parentheses. So my 2, which is really c over b, so I'm going to take my previous entry from my x's, so my x divided by 3. So previous entry, and then I'm going to do the opposite of that too. Looks like a plus, so I'm going to subtract. Then the other thing that I need to do is deal with that y value. So the last thing I need to do is the d, which is +1. Since it affects the y, you do exactly what you think. So I take my previous entry, which was times -1. Now, I'm just going to add 1 to it. And I'm going to go ahead and fill in my table for that as well. So minusing 2. Well, I don't like, I'm not a big fan of decimals unless I absolutely have to use them. So I'm going to keep everything as fractions. So if I have a -2 and a -4/3, what does that give me? 6 -10/3. So I'm just going to go ahead and fill in the rest of the table here. Okay, so I went ahead just using arithmetic and figured out what needed to be in my table. And so now what I have is I have my final points. So, and I think I'm going to put my graph on the original picture, see if I can actually get it to fit. So I would say my mother, which was my f of x, and this new function, which was g of x. So the last thing I'm going to do is I'm going to write what the points were originally and what they turned into at the end. So first point was -4/3, and it was transformed into -10/3 -2. So again, I'm just looking at the beginning of the table and what it got turned into at the very end. So I'm going to take a minute and fill all those in and pause. So if you want to pause and fill in and then check yours against mine, that would be great. So now I have my original points, my f of x, and my g of x, what they turned into. So I need to plot those, and then I also need to identify what really happened to this thing. So I'm going to do the same. I'm going to go ahead and pause for a second, plot these points. I don't think you need to see me plot them. And then I will come back before I plot them and we can connect the dots, just so we can follow the pattern. Okay, so as you can see, I shifted the screen around just a little bit because we didn't have room on the graph to put them together, but I thought that that would be helpful. So I've gone ahead and plotted my g of x points in gray. So I'm just going to go ahead and put a little gray box up here so I know which one's which, since my f of x came as the red one. Now, I just want to connect the dots. So I see the straight line segment there, so that one shouldn't be too bad. It's the other ones, though, that are a little confusing. So you want to make sure that you connect from left to right, but since there are straight line segments and there is a parabola section or dip section on here, I think we need to identify what's happened and then we can connect the dots. So with the A, with the A out in front, let's take a look at what that did. Well, you took the y values and you times them by a negative number. If you take a y value and you times it by a negative number, then that means that you're reflecting it. And since the y-axis runs vertically, this A, and I'm going to color code to go with it, the A is a vertical reflection. Now, had we times the y by a number other than 1, there would also be some sort of a stretch or compress happening. But that's not what happened here. We only times it by 1, so it didn't get stretched or compressed. Okay, inside to the B. We took our x values and we divided by 3, which means we took an x distance and we shrunk it by a factor of 3. Since the x runs in the horizontal direction and we are dividing, this is a horizontal compress or horizontal shrink. Okay, moving on to the C over B. Now, the C over B is, again, what we did to the x, but it was the opposite of what it looks like. So it looks like we're plussing 2, which we really didn't, we subtracted. So to take an x value and subtract 2 from it, that means that you're moving it left 2 units. So we went left 2. Then the last one is that D at the end. The D affected the Y, and we added it. So we took the Y's and we pushed them all up 1. So we went up 1. So with that said, I think we can go back to the graph now, only because of the whole reflection part. So if this is vertically reflected, then that means that the straight line segment I see on the red graph on the left stays a straight line segment. So this is going to be a straight line segment. The straight line segment next to it stays a straight line segment. Then this bump on the right hand side, being vertically reflected, becomes a dip. So get a nice curve to it. Normally what I'd like to do is I want to look and see if what I did actually makes sense. So vertically reflected, yep. Horizontally compressed, yeah, it does look like it's been squished together from right to left. And then it's kind of hard to see the shift left and right, especially if there is a reflection involved. So there's our first one. Okay, another transformation. So this is still going to use the same mother function as from the previous page. This time the equation's a little bit more complicated. So we're going to do the exact same thing though. I'm going to get this all out in factored form. Oh, I still have my gray pencil going. Get this all out in factored form, and then we can start playing around with the transformation itself. So I'm going to show that this is 2 times the function, and I'm going to factor out a 2/3. Remember, I want it to just be a plain old x inside. Alright, so off to the side. I want to do the 2 inside divided by a negative 2/3, the coefficient in the front. Okay, so to do that, I'm going to times by the reciprocal. Alright, 2's cancel. Looks like I just get a negative 3. So minus 3 on the inside. And it really is worth your time to make sure that you factor correctly. If you don't, the whole transformation is going to be shot. So it really is worth your time. I also go through and distribute right now just to make sure. So negative 2/3 times a negative 3. 3's cancel. I get a negative 1. Negative 2 times negative 1 is 2. I do get back what I started with in the first place. All right. Now, you see at the bottom I already have my table set up for my mother, and now I need to start doing my transformation. So, first thing I'm going to do is I'm going to take my x and I'm going to divide it by the a. The a is the number I just factored out, which is the negative 2/3. My y, I'm going to times by the exact number that's being multiplied in the front, which is 2. So I have my operations. Now I just need to do the math. One of the things that I would recommend is if you're dividing by a fraction, this is the same thing, just as a reminder, as multiplying by the reciprocal. So you're just going to flip it over and multiply by that number. So I'm going to pause and fill in the values. You might want to pause and then check and see if you and I match. Okay, so although the function looked pretty nasty, timesing by negative 3/2 or dividing by negative 2/3 was actually pretty nice. I got rid of any fractions that were in the problem at all. So now I'm going to take those previous entries and I'm going to do the next part of the transformation. Oh, that's a negative 2/3. So it looks like to my x's, I am going to add 3. Looks like subtract, but it's inside, so do the opposite. And then my y, I multiplied by 2 previously, and now I'm going to subtract 3. So I'm going to do the same thing that I did before. I'm going to pause, fill in the values. I would recommend you pause and fill in your values as well, and then check and see and make sure that you and I match. Okay, so I have my table of values now. Now the last thing that I need to do is I need to write the original points and what they were transformed into based off of the transformation. So let's fill those in. Okay, so I've got all of my mother points set up, And so now I think I'm going to do the same thing and just plot what I got. So let's go ahead and plot those, and then we'll explain what happened and then connect the dots. Okay, I've got all of my points plotted, and I see the straight line segment again, but I'm not sure about the curves. So let's go ahead and identify what's happened here. So from the very first part, the timesing by 2, we took the y's and we times them by 2. Y's go up and down, so vertically, and timesing that distance by 2, we're actually stretching it. So we have a vertical stretch. So that's what the 2 out in front did for us. All right. Then the negative 2/3. All right, so let's do the negative part first. So I took my x's and I divided them by a negative number, which means some x value that was positive is now going to be turned negative. The x's run in the horizontal direction, so they are now being flipped. So what was positive is now flipped over to negative. So we have a horizontal reflect. All right. 2/3 can get a little iffy. So let's go back down to the table and look at the table. So I divided by negative 2/3. Okay, I'm looking at the multiplication part here though. I'm timesing by 3/2. So I'm timesing by 1.5. If you times something by a number bigger than 1, then you're actually stretching it. You're making it a greater distance than what it was before. So I think we have a horizontal stretch. And that's only because the number I timesed by, that fraction, was larger than 1. That's why. Okay. The -3 on the inside, that means that we're adding 3 to the x's, so that means that we're going right 3. Then the 3 on the outside, we subtracted 3 from the y's, which means we went down 3. All right, let's go back to the graph. So, type of reflections that I have just a horizontal reflect. So what was on the right is now on the left. All right, so to me it looked like this whole bump parabola looking thing is on the right side of the graph. Now it's going to be on the left side of the graph. I still have my straight line segment in the middle, and then that V on the left is now going to be a V on the right. So let's go ahead and key this K of X as the gray one. And that's our second transformation. Okay, our last example for the notes. It's still a transformation, it's just that now you have to create the function itself. In order to do this, you have to be comfortable with where the things are that are in the equation itself. So I think what I'm going to do is I'm just going to write down in general where things are located. So this would be my g of x function equals some number out here. This number represents the vertical, sorry, it affects the y's. This is the vertical stretch, compress, and reflect. They all go right here. So this is going to be our vertical stretch, compress, one or the other, not both of those, and reflect. It's all going to be right there. Then we need to have our mother. So if they tell you that this is based off of an f function, you got to put the f in there. All right, brackets. Then there's another number. This number tells us what happens to the x's. So it's the horizontal reflect, stretch, compress. So this is almost the same thing, except it's horizontal. And then immediately after that, I would have a set of parentheses and an x. Then in with the x. This tells you this is that right-left movement, because if you're shifting, so this is right or left, how much you're moving. Then the last thing is whatever number gets put out here at the end. That's affecting the y, so this is your up or down movement. So whenever I build a function, I do this. I put all of the blanks in, and then I just start sliding things in where they belong. So I'm going to take my g of x function, keep my little notes up there for myself, and then I'm just going to start putting blanks in. Oh, that's supposed to be a blank. And then my x, blank, parentheses, bracket, blank. Okay, so I have the bones all set up. So now I'm just going to start going through and seeing what I can do. It's the following transformed function of f. All right, so that means it's g equals, f is the function that's based off of. It's reflected over the x-axis. Okay, over the x-axis means that the y values are changing. So this is reflected over the x-axis, which means the y values are being reflected. The y values are the vertical values. That means that I have a negative sign out here because my y's are getting reflected. This is going to be compressed vertically by a factor of 5. All right, compressed, that means it shrunk. Vertically, y direction, by a factor of 5. So that means that my y's are going to get timesed by a 1/5 to be shrunk. So my y's are going to be timesed by a 1/5 because they're being shrunk. Okay, I'm being horizontally stretched by a factor of 3. Okay, horizontally stretched, that's my x's. Okay, to be stretched by a factor of 3 means that I am going to be timesing by 3, but I need it to be the opposite of that. So it's going to look like it's being divided by 3. So timesing by 3, stretched by 3. That means that that inside is going to be a 1/3. Because if it was a 3, I'd be dividing by 3 when I did the math, and that means that I'm shrinking, and that's not what's happening here. Okay. I'm going to be shifted 22 units right. Okay, that affects the x, 22. But if I want to go right, I need to subtract because it's got to be the opposite. And then the last one, do I have any more colors? The last one. We're going to be shifted 11 units down. All right, so that's outside, 11 units, and you do exactly what you see, so down. So now I have my function. The next thing that I would need to do is identify what alterations I made. Well, one way to do that is the color coding that I just did. So you'll notice that I color coded everything something just a little bit different. Or you can write the notes underneath it. Either way, you would be fine. So I'm going to write the notes underneath this. Okay, so all I did was fill in the information just like I did up on my notes above. And I just took it directly from the question itself. So you got to make sure that you're perfectly clear on what went where and why it went there.